Our journey through using the cosine law. So we're going to take this example that shows you a triangle with all three sides. And before we actually dig into the solution of this, let's just take a look at a couple of details. If this was a right triangle, okay, then the Pythagorean theorem would have to work, which means that the hypotenuse would have to be 20. And you would check and say, is 15 squared plus 17 squared equal to 20 squared? It's not true, okay? And that means it's not a right triangle. But just to say, if it was a right triangle, we could use different trig rules to find missing angles or sides. Secondly, we're looking at this question and saying, well, what rule are we going to need? It's either going to be the law of sines or the law of cosines. If you try the law of sines, the reason that won't work is that the law of sines requires you to have a side and the angle opposite, and so you don't have both of those things. You have to have the opposite angle from a side to be able to do this. Okay, notice, by the way, capital letters are for labeling angles, lowercase is for labeling sides. So the sine law won't work in the first step anyways. We might need it later if we want to look for other angles. So we're stuck with the cos law, and yeah, the joke cos law, right, for goes well with hot dogs. So we're trying to figure out which angle we want to find. My suggestion is always look for the biggest angle because it'll avoid any confusion whether this is an acute triangle or an obtuse triangle. We can't really be sure in this drawing whether that's supposed to be equal to 90, greater than 90, or less than 90. So the Pythagorean theorem doesn't work. We know it's not 90, but we could find the missing angle at the top, knowing, by the way, that the opposite side is going to be the same letter. So let's just go with this and my favorite three letters, MHS. And we're labeling these with capital letters, so it will be lowercase on the opposite sides. So 17 will be lowercase s, and the 15 will be lowercase m. Don't get confused or tricked into thinking that the h stands for hypotenuse. So since I'm looking for the angle at capital H, I'm going to set this up following something very similar to the way we do Pythagorean theorem. You would say h squared is equal to s squared plus m squared. The order of those two letters don't matter. And then we have this slack term, 2sm cos. And in this case, it's going to be capital H. This is the formula for calculating the missing angle or the missing side. Now, when we're looking for the missing angle, it's always a little more complicated. So there is a trick where you can actually isolate the cos h all by itself. It takes a couple of steps, and then you can actually put this formula directly into your memory aid. So let's take a quick look at that. I'm going to bring the negative 2sm cos h term to the other side, where it's going to wind up positive. So 2sm cos h would be on the left-hand side. And I'm going to bring the h squared to the other side, so I'm going to have s squared plus m squared minus h squared. Just a reminder, our goal here is to see, oh, I put the wrong h there. Our goal is to put the capital H all by itself. Now this is s times m, and so that would be divided on both sides if I wanted to get it out of there. And whatever you do to one side, you have to do to the other side. And that's going to give me cos h is equal to s squared plus m squared minus h squared all over 2sm. Now notice I haven't plugged in any numbers at all here because I'm trying to develop a formula. Brackets are really, really important when you do this, by the way, because when you go to do the division, you have to get that denominator worked out completely before you divide, and making sure you press equals after you calculate the addition on the top. So your final step would be, if I wanted h all by itself, I would have to take the inverse sine of this ugly bracket you get the inverse sine by doing second, did I say sine? Inverse cos. You would get that by doing second cos on your calculator. So s squared plus m squared minus h squared, all divided by 2sm. And as I say, get those brackets in there. And you just do the inverse cos of that whole expression. All right, sorry if that wasted your time, but just to say that's where it comes from, and you could actually stick this into your memory aid only if you understand where those pieces come from. So let's figure out what the measure of angle H is. I'm going to do it just by plugging it in. So capital H is going to be equal to the inverse cos of S and M are the 15, 17. So 17 squared plus 15 squared minus the hypotenuse, or our pretend hypotenuse, because it's definitely not a right triangle, divided by 2 times 17 times 15. Now, I chose some really some nicer numbers here so that the bracket is going to give me a nice answer. So you'll have to check this out on your calculator. But actually, I'll do it in 2 steps. So 17 squared plus 15 squared minus 20 squared is going to be 114. One more word about this is that when you work this out, if you had come up with a negative number on top, then that means it would be an obtuse angle. On the bottom, it's 2 times 15 times 17, so we could do that in our heads, 510. And you do the division divided by 510. Ooh, it's a pretty ugly number, is equal to cos to the negative 1 of 0.223529412, blah, blah, blah. Now, the reason I'm writing the entire number is to remind you to use that whole number, because when you're doing inverse trig functions, you often get crazy differences in the answers if you round it too early. Now, I'm leaving the number in the display. I'm just typing in second cos second answer, and it's going to tell me that this is 77 degrees rounded to the nearest whole unit, 77 degrees up on top here. If you didn't choose to do it that way, you would have to do some algebra underneath and just say 17 squared, 20 squared is equal to 17 squared plus 15 squared minus 2 times 17 times 15 cos h. And then you would work your way through this. You'd still come up with the same calculation at the end, 114 over 510, that you would have to find the inverse cos to work that out. I should have labeled this h, that's angle h. The next step after you follow this along would be to find the other angles. You're going to use the loft signs, the easiest way. I'm probably not going to finish this one off because I don't want this video to go too long. But now that I know the 77 degrees opposite to the 20, I would go 20 over sine 77 is equal to, and if I'm looking for, let's say, the measure of angle M now, I would say 15 over the sine of M. Cross multiply 20 sine M, right, when you multiply that up, is equal to 15 sine 77, and you would divide both sides by 20, and that ugly calculation is going to give you, because they would cancel, right? The sine of M would be equal to 15 times sine 77. Don't use second sine or anything like that. And remember, you go equals before you divide by the 20. So 0.7307, blah, 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 blah. And you got to go second sine on that. Sorry for the mess here. Let's go up there. M is equal to sine to the negative 1 of 0.73077, blah, 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 equals second sine, second answer in my calculator, 47 degrees. when I round it to the nearest whole number. And it should be pretty obvious how you're going to find your third angle. You're going to add the two together and subtract from 180. And you'll see that all three are acute. Hopefully this is going to be, like I said, useful to you. That idea of the memory aid, just use that if you understand it completely. And labeling on your diagrams is huge, okay? So that you know whether it's a corner angle or a side length. Have a great day.